Alright, we're still doing some partial fraction integrations. And the fraction we have here is numerator x squared plus x over denominator x to the fourth minus 3x squared minus 4. So we need to do two things. First, make sure it's a proper fraction. Degree up top is 2, degree on bottom is 4, so it is proper. And then we need to factor our denominator as much as possible. So let's see, let's just come over here. This is a quadratic type denominator. Let me go ahead and write my x squared plus x on top. I believe the bottom factors into x squared minus 4 times x squared plus 1. And let me look at this for a moment. I get negative 4. I get negative 3. Yes. But unfortunately, I can continue factoring this thing. I know I'm not the neatest. But x squared plus x on top. Our denominator will factor into x minus 2, x plus 2 from the difference of squares part, and then the x squared plus 1 cannot factor any further. So with that in mind, let's go ahead and set up our partial fractions. So we'll have x squared plus x all over x minus 2, x plus 2, x squared plus 1 in the denominator, and I'm going to leave room to right there. Okay. Got a lot to multiply by, so let's leave a lot of room. So then I need my partial fractions. So the first one will have a denominator of x minus 2. That's degree 1, so I only need a constant up top. The next one, in the order I have them in, they could be in different order, but has a factor of x plus 2. That's degree 1, so a constant up top as well. We'll call it b. And the last one, denominator x squared plus 1. That's degree 2. So I need a first degree polynomial up top, so a cx plus d. So four unknown coefficients up top, and 3 fractions. So going through, we need to cancel things out. So we'll multiply by x minus 2, x plus 2, x squared plus 1, which we know over here on the left will cancel all of those out. That's good. So this one might take a little bit of time because we got to clean some stuff up. And then the first fraction, the a over x minus 2, we'll multiply by the same thing. And the x minus 2 will cancel out. And then the second one, the b over the x plus 2, multiply by the same stuff. And the x plus 2 will cancel out. And the last one, cx plus d over x squared plus 1, will multiply. And the x squared plus 1 will cancel out. So let's knock those out. So unfortunately, everything on the right-hand side, we've got 3 fractions. All of them are going to require some type of FOIL. So let's just get down to it. Writing this thing out will look rather long. The left-hand side is x squared plus x, so we don't have a lot of things over there to compare it to. But let's see. Over here, the a term, you can do this on your own. I'm going to do it rather slowly in my head and talk through it, but I'll have ax cubed plus ax plus 2ax squared plus 2a. So you write that out and make sure you get the same thing that I'm getting. A lot of terms there. Alright, the b terms. It looks like we'll have bx cubed plus bx. Let's make it neater since it will be important to get it right. And then minus 2bx squared minus 2b. And then the last fraction, oh no, this is even worse. So I'm going to have to take an extra step here, I believe, just to satisfy myself. But it'll be cx plus d times x squared minus 4. And I hate to rewrite all this, so let me just kind of work that out over here to the side. So that would be, if I FOIL that out, cx cubed minus 4cx plus dx squared minus 4d. Let's make that d look better first of all. And then let's just go ahead and mark out this part that was above it. So we got all of this. All right, now we've got to find A, B, C, and D. All right, good luck. So the highest thing we got here is an x cubed. So the x cubed gives us A plus B plus C. Oops, excuse me. 0 equals A plus B plus C. Let's color code those. Well, we don't know what any of those are, do we? So let's keep going. X squared. We have one of those on the left. So that'll be equal to 2a minus 2b plus d. So there's not a cx squared? I guess there's not. So let's use a different color here. X squared so we haven't found anything yet, but we're working. Next we have just the x's. So there's one of those. So then there's A plus B minus 4C. Okay, and then for the constant, we have 0 on the left. And what do we have? We have 2a minus 2b minus 4d. Alright, so I didn't do the purple down here, so let's go ahead and get that. So, what color have I not used? This blue. We haven't used yellow. Yellow is a good color to use now and then. So unfortunately, I've got 4 equations and each one of them has 3 unknowns. Nothing has canceled itself out yet. What I do notice personally here is the first equation and the third equation. Here's a plus b and a plus b in the other one. So what I'm going to do is I'm going to write those 2 equations. I'm going to take 0 equals a plus b plus c, and I'm going to take the third one, which is 1 equals a plus b minus 4c, and I'm going to subtract the second one. You can do it a little bit differently, but in that case, when I combine them, I'll get negative 1, then I'll have a minus a, b minus b, and then c plus 4c, so that'll be 5c. So it looks like c equals negative 1/5. I was not anticipating that number. Let's see what happens if we continue from there. Can we use that to help ourselves in any other way? Doesn't really look like it right now. But I can use also the second and third equation to get D in the same manner. So if I look at the second and third equation, I can have, let's use black again, I'm sorry. 1 equals 2a minus 2b plus d, and that will be the fourth equation, 0 equals 2a minus 2b minus 4d. So if I do the same thing and subtract them, let's see what I get here. I get 1 equals d plus 4d, so I get 5d. So I get d equals a positive 1/5. So let's see if that makes sense. I think it does from what I'm looking at. Well, what that means is we can kind of go back and mix some of these equations together to kind of help ourselves out. So if you're not good with systems of equations, or you haven't done many that are very long, you might be in a little bit of confusion here, but just let me know. We'll try and work on them. So then let's take the first and second equation for whatever reason. Okay. So we'll take the first equation, which is 0 equals a plus b plus c, but we know c is negative 1/5. And let's take the second equation, which is 1 equals 2a minus 2b plus d, but d was 1/5. So let's see what we could do here. We could move these 1/5 over, and there's nothing wrong with that. But let's take the first equation and multiply it by 2. Because I'm going to try and cancel out these b's. And if I do that, make that look a little bit better. Let's say times 2. So 0 times 2 is 0. Then we'll have 2a plus 2b minus 2/5. And then let's bring the other equation over. It'd be 1 equals 2a minus 2b plus 1/5. I'm going to add these two together to get rid of the b. So let's see what happens here. So if I add these together, I will have 1 equals 4a, no b's, and then minus 1/5. Oh, so continuing that on, we're going to run out of room here of knowing what we're doing. But we'll bring the 1/5 over, so that means we'll have 6/5 equals 4a. And then we'll divide by the 4, so a equals 6 over 20, which will be a little bit better as a equals 3/10. And whoo, let's see. Let's use one more problem here. Since I can see it, let's use the third equation, because we don't have b yet. We're going to run out of time in this video, but let's see. 1 with the third equation, the purple one. 1 equals a, which is 3/10, plus b, which we don't know, minus 4c, which will be, c is negative 1/5, so minus a negative will be a positive, so it'll be plus 4/5. So let's see here. Let's get everything in terms of tenths. 10/10 equals 3/10 plus b plus 8/10. So we got 11/10 on the right. We'll subtract it over. So 10/10 minus 11/10 would be minus 1/10 equals b. Okay, let me make that a little bit neater since it's kind of important. Alright, this is going to take a little bit of work because everything is way up yonder. So let's see. What were my fractions? My first fraction was a over x minus 2. Okay, so now we're doing our integral. A 3/10 over x minus 2 plus my second fraction was over x plus 2, b over x plus 2. Ooh. So b is negative 1/10 over x plus 2, and the last one is over x squared plus 1, and that would be cx plus d, so that would be negative 1/5 x plus 1/5. and we'll have to integrate this in the next video.